calculus, we learn how to differentiate and integrate functions. So it's very important to first learn exactly what a function is. At the same time, we're going to learn about inverse functions, so we can talk about both functions and their inverses. So we can write a function as y equals f of x. The values of x that a function takes is called the domain of the function. And the values of y that are returned by the function is called the range of the function. Not all graphs are functions. If we look at a graph of a circle, say, so this is our x-axis, this is our y-axis, and I draw a circle here. We have the circle is defined by the equation x squared plus y squared equals r squared. I can take r equal to 1, so this is the unit circle. This is not the graph of a function. It's not the graph of a function because one of the most important requirements of a function is that for every x that you give the function, it returns only one y. For the case of the circle, if we give this value of x and then we draw a vertical line here, we see that it returns two different values of y, a positive value and a negative value. We say that this graph fails the vertical line test. If a vertical line intersects the graph in two places, then it is not a graph of a function. On the other hand, we can take this circle and just draw the top half of the circle, so the semicircle would look like that. This is our x-axis, this is our y-axis. This has the function y, then solving for y is the square root of 1 minus x squared. So just the positive square root. And then this is a function because it passes the vertical line test. So for every value of x, there is only a single value of y. What is an inverse function? Inverse function. We can obtain an inverse function from a function by sending x to y and sending y to x. And then we can write x is equal to the inverse of f. We denote that as f superscript minus 1 of y. Okay, so this is the notation for an inverse function. We can look at an example of an inverse function. So let me draw the function. This is our x, this is our y. Let's draw the quadratic function that looks like this, right? So this is the function y equals x squared, right? It passes the vertical line test, but this function doesn't pass a horizontal line test. So if we put one point on the y-axis and draw a horizontal line, we see that there are two x's that give that y, right? We can write that as y is equal to plus or minus x squared. So for each y value, there are two x's. So this function then doesn't have an inverse. For a function to have an inverse, it has to pass both a vertical line test and a horizontal line test. We can restrict this function. So instead of y equals x squared for all x, we can consider y equals x squared for non-negative x. And then this function here would satisfy the vertical and the horizontal line test. This function has an inverse then. We can calculate the inverse. One way of doing that is to draw the line that looks like this, which is y is equal to x, and then take the mirror image of this function around the y equals x line. That's equivalent to sending x to y and y to x, and that would look like something like this. And this function here, so this is the function y equals x squared. This is the well-known function y is equal to the square root of x. The square root of x is the inverse function to the function x squared. Okay, there's one more consideration that we will use quite frequently in our calculus course. If we look at the f of the inverse function, right, the inverse function would send x to y and y to x, and f would reverse that process. So this is equal to x. As an illustration here of our quadratic, f is the square function and f inverse is the square root. So that says that the square of the square root, so the square of square root of x is equal to x. We know that to be true. The other relationship then would be f inverse of f of x, right? F sends x to y, f inverse sends y to x. That gives us back x. And the example here then would be f of x is the square, the squared function, and the inverse is the square root. So the positive square root of x squared, we all know, is equal to x. So let me summarize. We're now defining functions and their inverses. We write a function as y equals f of x. All the values of x that a function takes is called the function's domain. All the values of y that the function returns is called the function's range. For a graph to be of a function, it has to satisfy the vertical line test. On the other hand, an inverse function is obtained from a function by sending x to y and y to x. For a function to have an inverse, it must also satisfy a horizontal line test. Finally, there are two identities that will turn out to be very useful. F of f inverse of x returns x, and f inverse of f of x also returns x. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.